Hi there, Mr. Sutton here, bringing you the IM374 Part 1 homework solutions on applications of right triangle trigonometry. For this word problem, let's start by getting a picture. So we have an airplane climbing at an 11-degree angle of elevation. That tells us we're going to have a right side up triangle. And our angle of elevation is going to be this angle here between the horizontal and the hypotenuse. So there's 11 degrees in there. We want to find the ground distance it has traveled when it has attained an altitude of 400 feet. So the altitude of 400 feet, that's the height of the plane. So here is the plane all the way up here at the top of the triangle. So that's a vertical distance of 400 feet. And we want the ground distance traveled. So that's this horizontal distance down here. So we'll call that x. Now to solve this, I've got, based off this angle here, I've got the cross side, the opposite side over here, and this non-hypotenuse leg down here. This is the adjacent side. So opposite, adjacent, that's TOA out of SOHCAHTOA. So that's going to be tangent equals opposite over adjacent. So I can write tan of my angle, 11 degrees, equals my opposite side, 400, over this adjacent side of x. And now to solve for x, I have to multiply by x and divide by tan 11. So I have 400 over tan of 11 degrees equaling x. And now let me use the calculator. So 400 over tan 11, that's going to come out to 2057.8, and that's going to be in feet. On this problem, we're told in order to reach the top of a hill, 250 feet high, we have to go 2,000 feet along an inclined road. And they want the angle of elevation of this road. So angle of elevation, that's our tip-off that we have a right side up right triangle. And our hill, and this is our hill here, is basically this triangle, is 250 feet high. So that's this vertical dimension. And they said you have to go 2,000 feet along an inclined road. So the road is the hypotenuse here that leads you to the top of the hill. So that's 2,000 feet right there. Based off this, they want the angle of elevation. That's going to be the angle between the ground floor here, or the horizontal line, and the hypotenuse. This angle right here. So in order to find that, we've got the opposite side, the cross side here. We've also got the hypotenuse. Opposite hypotenuse, that's going to be the sine function, equals opposite over hypotenuse. So we can say sine of x equals my opposite side of 250. Divided by my hypotenuse across from the right angle here, that's 2,000. In order to get x, I have to take the inverse sine of 250 over 2,000, which I will now do on the calculator. So here we are on the calculator. To get sine inverse, I did second sine, and then pressing enter on that, we're getting about 7.2, and that's going to be in degrees because this is an angle. On this problem, we have a ladder leaning against a wall with an angle of depression of 74 degrees. We're told the foot of the ladder is 6.5 feet from the wall. How long is the ladder? So angle of depression, this tells us for this right triangle trig problem that we're going to need a upside down triangle like so. And the angle of depression, that's always going to be between the horizontal and the hypotenuse side of the triangle. So that's this angle right here, 74 degrees. Now we're told the foot of the ladder is 6.5 feet from the wall. Well, the way this is drawn here, the foot of the ladder, I mean this is the ladder leaning against the wall, the hypotenuse. The foot of the ladder is this distance down here. That's equivalent to this distance up here at the top of the triangle. So in terms of what we're going to stick our 6.5 on, that's going to be the top of the triangle. But we know it also represents this other triangle that you could draw down here if you wanted to. Now, how long is the ladder? Well, that's the hypotenuse again, so we'll put an x on that. And now, in terms of solving this, we have the hypotenuse, we have the non-hypotenuse leg of the angle that's touching the angle, so the adjacent side. Adjacent and hypotenuse, that's going to be ka from SOHCAHTOA, so that's cosine equals adjacent over hypotenuse. So we have cosine of our angle of depression, 74 degrees, equals our adjacent side of 6.5, divided by the hypotenuse of x. And then to solve for x, I just have to multiply by x and divide by cosine of 74. So we have 6.5 over cosine of 74 degrees. Let me do the calculator for that now. So plugging that in, we end up with 23.6 if I round to the nearest tenth, and that's going to be feet So that's going to be how long our ladder is. For this one, we're standing at the top of the Eiffel Tower. Lucky us. That's 984 feet tall. I bet it's a great view. And, of course, we're thinking about food. We're looking down at a baguette in a basket, which is 50 feet from the base of the tower. We want to know the angle of depression to that baguette for whatever reason. Well, since we're doing angle of depression, that's an upside-down right triangle, like so. And in terms of our dimensions, we're at the top of the Eiffel Tower, which is 984 feet tall. Okay, well, here's the Eiffel Tower over here on the left, and you're at the top looking down here, down at the bottom of this triangle at the baguette. So the height here is actually the same as this height over here for the triangle, and that is 984 feet. And now we're told that the baguette itself is 50 feet from the base of the tower. So this is 50 feet down here, but of course there's no triangle drawn down there, so we're going to use the height, or the ceiling rather, the top of this triangle to represent that 50 feet. So we're trying to find the angle of depression. That's this angle in here between the horizontal and the hypotenuse. Well, how do we go about doing this? Let's look at what sides they gave us. So we have the side across from the angle, that's the opposite side, and then this side that's touching the angle but isn't the hypotenuse, that's our adjacent side. So opposite, adjacent, that's the tangent function, TOA. So we can write tan of theta equals opposite over adjacent. So we can say tan of x, the angle, equals the opposite side of 984 divided by that adjacent side of 50. And to actually find x, we have to take the inverse tan of 984 over 50. We're going to go ahead and do that now on the calculator. So on the calculator, to get inverse tan, again, we have to do second tangent, and then 984 over 50 inside. That gives us 87.1 if we round off to the nearest tenth, and that's going to be in degrees.